Good afternoon to guys. Right, thanks for being here. I came all the way from Singapore to present this one. It's an interesting challenge what we gone through actually. That's what I'm going to present here. You could go to Gamma or ChatGPT and put this topic, and then you could able to get that a lot of. How do we move to the next one? Okay. You can get lot of slides definitely, right? But the thing is, right, it's not about the content. It's about the challenge what we face and how do we came to that, the conclusion. This is going to solve our need actually. So I can't tell that the whole product, but I can give the gist of it, right? We got to that to be implement one of the new solution into the existing product as a plug and play. Is reconciling that data. So we will have the data in our ledger, and then we used to get the data from that our client. We have to recon that data together. The data will be coming in millions. But the thing is the time to deliver the response is a matter. That's what going to give that a money and as well as the value to that system. So what it came to us is unrealistic expectation from the product. So the last slide I will show that what is that unrealistic expectation. So then we tried with a lot of solution, lot of ideas, and it worked definitely, but it didn't give that the expected outcome actually. So then we have to go to that lot of different ideas, and finally came to this conclusion, and we implemented and it solved our need also. Further to that, right, we should able to fine tune that current one and then able to bring up the more value. That's what we are keep on doing it. That's where we use that our QA team and dev team to explore further and further. If you go this one, so this is what our whole ingestion actually, how this going to be talking about, right? It's a scaling. When the Kubernetes, right, Kubernetes is a very good system. It take care of that everything top to bottom. We just simply sit and then we just deploy our workload and it will work but the same time, right, when the workload goes, it may not be a static workload, right? It's going to be a dynamic, and we have to solve the problem what we wanted actually. The solution what we built is actually right using a couple of AWS resource, and then as well as one of that the realistic API which is built by the Facebook Meta. So they built one of that API which will be detecting that overall the instrumentation, right? How much is possibility on the next hour or next minute. So that's what helped us to scale our workload as appropriately, and definitely it helped us also for a very good way actually, right? So this is what the solution. I'll give you guys a couple of minutes to digest this one. It took us a quarter, right? It took one full quarter, 3 months to come up, because we tried with that simple HPA solution initially, and then we did our own way of coding and our own way of monitoring that, and then able to bring and low and high and all. Nothing works, and no one's happy from the product. They said no, we will not able to go to the client and say that the solution is going to do that fulfill that their need actually. So the thing is, right, what we get from the client to that S3 bucket, we get a file which will have that 500 to 3 million records content file actually in a one file. It could be 10,000 or 3 million record in one file. What we need to do is we have to explode that file into how many record into be a separate message, and each message will be reconciled with the original database in our side actually. Then we have to produce that result and then have to store into the database. So then the remaining part, right? All guys know right how to do the monitoring, how to do the dashboard and all. Those are very simple, easy stuff, right? Any full stack engineer can create with that our new cloud AI, super gigantic like now the presentation. But the matter is like no the behind the scene how we going to achieve this one. That is what is important actually. So what we did it actually, we get the file. Upon the file comes to the S3, it will be like no goes to the SQS. The SQS the same time right like no do the two things actually. One will go to the cloud watch, how many times the files are coming. The second one is that like now the same SQS will be listened by the Kubernetes pod. Whenever that is CloudWatch like now get that like now file incoming, it will send to that Prophet API, right? Like now this is developed by Facebook. Now Meta, right? Like now it's developed by them. It's a simple, very good like no, it's a Python library. It like now able to understand that over the time. It doesn't work in the day one. You have to like now train that actually, right? Like now over the period. 1 day, 1 week, 2 week, then it will give you that like no unrealistic like no numbers actually. Okay, so I learned last 1 week, the time 1001, possibility is like no 1 million. 1007 could be 3 million. So it will do some calculation, which will be like now if you go and read about their paper, you will understand how they did it actually. It's a simple Python library. You have to make that and then run it in the Kubernetes. So what we did actually, we running two pod actually. It's a predictor pod. What it does actually, the predictor pod try to understand the SQS, what is the possibility of the next minute arrival of the file numbers. Then it will send to the Prometheus. It will send it to the Prometheus. The Prometheus will be able to understand, okay, I'm getting like 10, 100, 1,000, million, something like that. Then it will create a cage actually. It will give you the cage. So that 1001, it will say 10 pod. Okay, 10 pod will be able to solve this problem. 1002, it will say that like a 100 pod. 1007, it will be like no 200 pod. So like this, right? Like no, because we using that like no the ECS, we don't have any problem. The only the matter is here is you have to give a sufficient time to scale, which means you have to scale the pod upfront before the file comes. Who is the decision maker? Like no, you need to scale upfront the prophet. He will make the decision. Based on that, the moment arrival, it will detect that like now it will understand that okay, next 3 minutes, next 10 minutes, or next 1 hour, this many files can come. Because that's what the sequence came yesterday and last week, last 2 weeks. It will try to understand and then give that number to the Prometheus. Prometheus will understand, okay, now 200, 300, 500, something like that. Then use the KEDA. KEDA is an event-driven program. It's very simple, right? If you listen to that any event-driven thing, actually, like might be able to like now just scale that pod. So the pod will be scaled actually. The minute 1001, actually like now the overall work, right? It happens maximum 40 minutes. That's what our period. Maximum 40 minutes only the client will send the file. But we wanted to process it within 40 minutes. We don't have any restriction on that like now overall resources or any cost or something. We wanted to ask appropriately like now do it and then put it like now the right way. So it will, we saw that it was scaling up to 2700 pod. Every pod have only like now we have 4 GB memory and then 2 CPU. That's all. It's a maximum that resource actually, right? Like now. And then start with that like now 1 GB to 4 GB and then start with that 0.5 CPU to 2 CPU. That's all. So we don't spend a lot of like now resource. The cost will be like now very less. It will go 2700 pod. Then the next like now 2 minutes later, like a 1007, it might be 2700, and then 1009, it might be like now comes to that like 1000. Slowly it will go, and then it will detect that like it will go up, and then it will come. Next 40 minutes, the pod will go to 0. So we don't run. It's not running 24/7. It runs only 40 minutes. So the good thing is, right, like now, when we finish this one, we split the file into a separate record and put it into the another queue. That is what the processing queue. There is a worker pod. That pod also like now send that to the CloudWatch. CloudWatch will go to Prophet and goes to Prometheus, and Prometheus will go to that like now the give the cage, and then the KEDA will scale the worker pod. The worker pod is the one is that like now they're really doing the checking, because we have superstars in our team. They know very well how to do indexing, how to get that query performing as quick as possible. It's even though we have billion records, they done the magic and then it able to give you that 3 millisecond the record response. If you give that the sequence ID and then if you give that the particular column in the NoSQL, it will come within 3 seconds, 3 to 5 seconds actually, right? Sorry, 3 to 5 milliseconds actually. So the worker pod will do the star 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 is the magic what we do actually. Then it will go to that RBS. Is overall we able to achieve this solution. This is what our target is given. Per second, we wanted to achieve 10K. When we initially started this application, we able to achieve only 700. Okay, so that's what the presentation we gave to that product. No, we can start with that, but we want that at 10K. So it took a quarter, 3 months almost to reach that 10K. Our ultimate aim is at 10 million only, but we reached to 36 million. We showed that demo to that product, we can scale up to 36 million. This is where the magic our QA team and as well as the people are came into the picture. Oh, we can put kind of an NFT test, okay, full put 5 million, 5 million, 5 million they will put. And then we said okay, just do little bit automation. First send 1,000, send the 1 million, then next 3 minutes send the 2,000, 1,000, something like that. We want to see the magic of the profit. So the previous slide. So we want to see that the magic of profit. It's really worked awesome way. We solved and then we able to achieve that overall 10K per second. And then it went to that we could do that 36 million. But the ultimate aim is the client will send only 10 million. So maximum 10 million per day within an hour. The SLA is within 40 minutes we have to do that. In overall, the solution is really helped. I think this solution could be eye opener for the lot of people. So they might be having this kind of the asking, right? The product team. So if you think about it, you think that some of that predefined APIs, right? Which gives that solution ultimately, you could achieve this as soon as possible, right? Without any struggle. So this was overall my presentation. And here I'm open to connect with people and then as well as open for the questions. Yeah, please.
How does Profit know the size of the files? Because you pass the file information and CloudWatch.
Yeah.
You might know the number of files.
Yeah.
But how do you know the size of each file? Each file would have different number of records.
Yeah. So it's simply in the Prophet API, the Python library, we wrote a couple of a wrapper. We will try to get that number of rows using the WC, right? We worry about only the number of rows because every row is considered as a one record. So it doesn't matter the number of the file size. It's only it depends, right? You could be thinking about the file size, but our solution is working towards only number of records. So we work with that 1,000 record or 1.5 million records. So that is what the important here actually. Yeah.
How does Profit work? Can you just explain a little bit?
Yeah, so Profit is it's just a small Python library. So what we need to do is that we have to install that Python library into the Docker image, and then you can run that Docker image into the Kubernetes. This is simple, right? What you have to do is you have to use the endpoint, Python endpoint, whatever you are exposing, you have to ingest that the data. If you ingest the data, it will create that JSON object and then it will create that in memory actually. After the in memory, it will start store into that a PVC. So we store it in the PVC. So it will start learning. It's start learning, right? Today how many files are came and how many things are came, and then tomorrow what is the prediction. So it will give you the two endpoint. So it's actually they have multiple endpoint. We use the two endpoint. One was the ingestion, another one is for that getting the prediction actually. So if you go, they have a very good tutorial, which is open source actually, right? Like now it's a very good tutorial. The tutorial will show you that like now some of that existing implementation, how to use it actually. If you go through that one of the tutorial, which is that in the GitHub, like now somebody even have that like now implemented that one is for the purpose of gaming. They wanted to like now detect that the gaming actually, right? Like now how many user like now playing for the game or something. So then they will provision that like a pre-built pod. They wanted to pre-build the pod actually, the gaming pod actually. So for that he wrote like some repo. It's available. If you go, it's a very simple. Theory wise, it's very simple. But when you build with a Docker and then you have that, you have a two endpoint. The two endpoint will solve your problem actually. So any other questions? Okay, good. Thank you very much, and I hope you guys are enjoying this session. And then go to connect with us if anybody wanted to talk to me. Thank you.